Hello, and welcome to your first lesson in Biz 2721, Statistics for Business. In this lesson, first I'm going to start by explaining how all of the lessons will be laid out in the course, and then we're actually going to start to cover some introductory content on what statistics is for Learning Outcome 1 of the course. So all of our lesson notes in this class are going to be in Microsoft Excel. And the reason for that is because in Excel, we're going to apply many of our statistical formulas throughout the course. So rather than doing calculations by hand on all of your assessments in the course, we will be using Excel to speed up the calculations and help you to maintain accuracy. That means both applied activities and your exams will also be within Excel. So to keep everything Excel based and to make things as clear as possible, your lesson notes will also be in Excel. Every time you begin a new lesson, they'll start with this title page that tells you the lesson number, you have the course header image, the name of the lesson, and a spot for your name and student number. Because the lesson notes will be your own personal files that are just for learning, you don't have to add the content here, but it's meant to look just like your assignments will also look. And on assignments, you'll need to add your name and student number. So it's there so you can get in the habit of adding them. Most of the data sets will come from our free textbook, Introductory Business Statistics. That's an open text online. Unless otherwise noted, if I tell you where another data set that we're using comes from, I'll usually use a link to provide the source if it's not from that textbook. After the first sheet of the workbook that has the header image and name of the lesson, there will be sheets for all of the learning objectives that we're covering that day. So you can see here that we're going to cover learning objective 1.1 all the way to learning objective 1.6. So in the first sheet, we're actually going to talk about both learning objective 1.1 and learning objective 1.6, and then we'll work our way through 1.2, 1.3, 1.4, and 1.5. So you can see what the actual objective from the course outline is up here, and the reason I label them by objective is so you can keep track of what you're learning, and also it shows you that we will be covering all of the content from the course outline throughout the semester. So your lesson notes will be structured in this way throughout the course. By keeping the structure the same, hopefully it will make your learning easier as you work through these lessons individually and at your own pace. So without further ado, we're going to start this first lesson, which is an introduction to what statistics and data are and how they can be applied. So the first two objectives we're going to cover within this first sheet are to discuss the differences between descriptive statistics and inferential statistics, and the second one will be to explain how statistics can apply in businesses. Many of you might have taken a statistics course in the past, but whether you've taken statistics before or this is your first statistics course ever, we usually always start by defining what statistics is. In this course, every time you see a box with that kind of pinkish burgundy fill, that means we're going to be filling in a definition. So the first definition for our course is that statistics is the study of proper collection, analysis, and interpretation of data. As we fill in the definitions throughout the lesson today, I want you to fill them in your own Excel sheet on your computer. So don't just watch the video, fill in the definitions as you go, because these lesson notes are going to be important for you to refer to as you work on applied activities that are graded in the course, as you work on homework questions that are ungraded, and as you prepare for the final exam. So you want to fill in these notes so you have them throughout the rest of the course. So statistics is a group of tools and techniques. It is a field of study, but it's also the tools and techniques that we use in order to collect, then analyze, and finally make any kind of meaning. That's the interpretation from a set of data. Not only is statistics the whole field of study that people can learn about and take courses in like you are doing now. But when we talk about a statistic without the S on the end, so just a statistic, that's actually any number that's calculated from data. So if you're reading a news article or if you're watching videos, you might see them pop up all the time. For example, the unemployment rate in Canada is 6.4%. That 6.4% is a statistic. Or if someone says the average income of a Canadian in 2022 was $57,100, that 57,100 is a statistic. Or Netflix has 277.65 million paid subscribers in the second quarter of 2024. Currently, Cambrian College has 94 programs. The 277.65 million people, the 94 programs, they're a count of a number of something, and those are also statistics. So we have a couple examples here, the percent, the dollar amount, or just a number of people or number of programs. They're all different numbers from data that are a statistic. One word that I keep using over and over again within the definition of statistics, and even here when we talked about them, is data. But data actually has its own definition as well. Specifically in the statistics course, when we define data, what we really mean is information. Usually it's a number, but it can also be a fact about something. Something as simple as a color, or in your case, what program you're in or what program you took before coming to Cambrian, is information about you that we can consider data. Specifically, when we talk about data, we're collecting it to help us analyze our data or help us come to a conclusion that could be useful in the business context, specifically in this course. Obviously, you use data in your everyday life. You might check the weather this morning and see that it's supposed to be 20 degrees, so you decide that you're going to wear a t-shirt instead of a sweater. You might also check your grades in a course. And if you find out you got a 60% on an assignment, that might influence you to study harder or put more time into the course for the next assignment. So the purpose of data is you usually want to try to use it in order to make some kind of decision. In order to actually use the data, it has to have some kind of context to help you understand it. Let me explain what I mean by that. So here's some information about me. Jenna for yes, very important. If you know your instructor's name is Jenna, you can probably guess that Jenna is the answer to a question like, what is your name? But what about the for, or yes, or what do I think is very important? With no context, you don't actually have any meaning behind this data. It's really just words, and you don't know what questions those potentially answer. So this is information, but it's not well organized. So when we talk about data in a statistical sense, we want it to have a context or an organization so that we know what it means. One really easy way to organize the information is in a tabular format. So for example, I now have the names of 3 people, not just Jenna, and their answers to some questions. So Jenna is teaching 4 classes, so the 4 was actually the number of classes. Now that it's in this tabular format, I understand what the 4 represented. Yes was the answer to the question, do I have class today? So if I'm teaching a class today, that gives me the context for what the yes answer was. And the very important was how valuable I think the statistics course is. I think it's very important as your professor for the course, but that shows you what the answer, what the question that was asked was. How important do you think the course is? And I thought it was very important. So instead of just saying Jenna for yes, very important, when I organize it in this table format that tells me what the values correspond to, that's what's meant by a context for the data. You can then even have the answers for more than one person. So if these are Jenna's answers, maybe Chris's answers are that he has 3 classes, he does not have class today, and he thinks the class is somewhat important. And if we have Craig, maybe he's teaching 5 classes, he does have class today, but he doesn't think that this is the most important class. So in that way, we can see different people's answers, and we've given our data a context. once we have data that actually has a context, so that means we understand what the values mean, then we can actually start to perform the study of statistics, where statistics are tools and techniques to collect and analyze the data to make meaningful decisions from it that will help you in business. When we talk about doing statistics, we're going to learn two main types of statistics in this course. We call those two main types descriptive statistics and inferential statistics. Next, we're going to define in our burgundy boxes what the differences are between these two methods. So first, when we talk about descriptive statistics, it's actually the first type of statistics we're going to learn in this course. So for about the first half of the course, we're just going to discuss descriptive statistics. And then in the second half of the course, we're going to move on to inferential statistics is the name for it. So the first one, descriptive statistics, involves organizing and summarizing your data. So putting your data into a table, making a chart for it, like a pie chart or a bar chart, calculating a percentage, calculating the average, calculating the standard deviation. These are all values we're going to learn to calculate, or charts we're going to learn to create in the course. And any kind of organizing or summarizing of your data is considered descriptive statistics. The next type of statistics you can do after you've done some descriptive statistics, so organizing and summarizing your data, is inferential statistics. And inferential statistics is all about trying to make predictions about a population based on a sample. Later on in this lesson, we're going to define what a population and a sample are, but for now you can think of descriptive as just summarizing the data that you have, and inferential as trying to make a prediction or a generalization about data that you don't have. The last part of the learning objective that we said we were going to talk about in this sheet wasn't just the definition of statistics and descriptive and inferential, but also how statistics applies to business. So I have a couple of examples of businesses that you might be familiar with and different ways we could apply statistics. So Starbucks, it's a company that's famous for its coffee. We're going to talk about how you could apply descriptive and inferential statistics. So descriptive can be something as simple as counting, finding percentages, finding averages. The example I gave is if you count the total number of caramel ribbon crunch frappuccinos sold at the 4 Starbucks locations in Sudbury, that would be descriptive statistics. That's just one example. There are many, many others. You could even look at the average income that people that work at Starbucks make, or the average spending in a single order in Starbucks in Sudbury or across Ontario or across Canada. It would just be some kind of summary that's relevant to Starbucks. So here it's the total number of frappuccinos sold. Another example would be total spending per order on average, that we could calculate that average amount. Inferential statistics, again, is about making a prediction or a generalization. So let's say that the manager at the Paris location of Starbucks in Sudbury, so on Paris Street, wants to test a new drink. So what they would do is they'd test the new drink maybe for a week or two, and they would use that sales data to see if it sold a lot, to try to predict if it would increase sales at other locations across Ontario. So again, they're using data that they do have, which would be the sales for that test period for a week or two, to try to predict if it will increase sales at other locations in Ontario. The second example is Cambrian College. Because you're all students at Cambrian, I knew that would be a business you're all familiar with. And the college is a business since it earns money. An example of a descriptive statistic for the college would be that it reports a percent of domestic versus international students. So right now, Cambrian has about 75% domestic students and 25% international students. There are so many other numbers that could be reported for Cambrian. We could look at the breakdown or the percent of students enrolled in business versus IT versus arts, like all those different departments at Cambrian. Something as simple as just the total number of students that attend Cambrian could be a descriptive statistic. If we want to move on from that summary of information that we can have into making predictions or generalizations about what will happen in the future, maybe we could try to use the enrollment numbers from this semester to try to guess how many students will be enrolled in January 2026 in the next semester. So that would be a prediction into the future, which is inferential in nature. In the table, I left 3 blue boxes. Those blue boxes in the note and in all the lessons will be used to indicate something that we're going to fill in together or an example to fill in together. So the goal here would be for you to think of a business on your own and an example of how descriptive and inferential statistics could be applied. So it could be any business. Descriptive would be any kind of number you can report. So think about something you could count, a percentage, a dollar amount, any value you could report. So if I chose a clothing store in Sudbury, let's say Positive Inception, because it's a brand that's unique to Sudbury and was started by a Sudbury local. A descriptive statistic could be like average cost per clothing item sold. So let's say they have some sweaters that are really expensive and cost $100 versus t-shirts that cost only $20. We could average that out based on what they sell the most of and figure out the cost per clothing item sold. For inferential statistics, they're trying to make predictions or generalizations. So maybe they could do something like use sales in Sudbury to try to predict if they could expand to new markets in Southern Ontario. So they look at the sales that they do have to try to predict if they could be successful in another market. Maybe they could even do a test, like a pop-up at a mall in Toronto and see what their sales are there to try to see if they would sell in general in Southern Ontario. So that's the idea. I came up with one example of a clothing store on the fly. You should try to think of your own example of any business and an example of how you could apply descriptive and inferential statistics. That is it for the first sheet in the lesson. So we're going to move on to the next one, where in the definition of inferential statistics, we saw that you're trying to make a prediction about a population based on a sample. So our next goal in this lesson is to learn what population and sample data actually are and how they can be defined. So if you want to perform statistics, part of the definition of statistics was to collect information or collect data. So the most common way to do this is through some kind of sampling procedure. So in the study of statistics, we call the survey the name for how you'll ask people questions to collect information. So you've probably completed lots of surveys in your life, even when you go and make a purchase, like at a grocery store. A lot of the time now you'll find a QR code at the bottom that will say like, please fill this in to let us know how we did today, and you'll have a chance to win a gift card. That's a simple example of a survey to collect information. So how statisticians or people who do statistics collect information is through a survey. And why they do the survey is to try to do inferential statistics. That's a fancy way of saying to make predictions or generalizations about a whole population. So what is a population? That's our next definition. It's any whole collection of objects, people, or things that we want to learn about. So the population changes depending on what you want to learn about. If you're interested in Canadians, the whole population of Canada, which is about 40 million people now, could be the population under study if you want to learn about Canadians in general. But if you're studying just people in Sudbury, where Cambrian College is located, Sudbury could be your population. Or if you're only interested in learning about students at Cambrian College could be your population. The population is whoever you want to learn about. It could even be any person in the whole world. And then it would be the global population is who you want to learn about. So it really depends on your question or what information you want to collect. When we use the word sample, a sample is a part of that population that we examine in hopes of learning about the whole population. So as an example, let's say that I wanted to learn about students at Cambrian College. Right now there's about 5,000 students that are attending Cambrian. So the population would be all of those 5,000 students. If I want to learn if students are satisfied with their program, let's say I only ask 100 students to tell me, are you satisfied with your program, yes or no? The whole population of students would be all 5,000, but the sample would only be the 100 students that it asked, are you satisfied with your program at Cambrian? So why would I ask only 100 students instead of asking all 5,000? There's some pretty good reasons why, and you can probably guess some of them. The first one is it would take way too much time for me to try to calculate or contact, all 5,000 students at Cambrian College. To even try to find these people, ask them the question, it'd be much too time consuming. So it'd be way easier for me to ask 100 people than to ask 5,000. The second reason is cost. A lot of the time when you're doing a survey, you may need to print materials. You have to hire somebody to actually go out and ask the people questions, and it just costs too much money to ask that many people. A third reason is it could actually be impossible to survey the whole population. People are always dying and being born. So even the census in Canada, the census is where the Canadian government asks every single person in Canada to report on things like how much they make, how many people live in their household, their demographic information, all of that kind of stuff. But because people are always dying and being born, the census is only like a snapshot in time. People will maybe fill in the census and then die by the time it's mailed in, or a new person could be born after somebody filled in the survey. So it's always only accurate as a snapshot in time. Another example of why I mean it could be impossible is, let's say you're trying to sample water in a lake. You can't actually sample every single molecule of water. Water's always evaporating or absorbing into the ground, or more rain could be added into the lake. That makes the water levels go up. You wouldn't want to drain the whole lake to sample the entire lake to test the water or bacteria levels. So sometimes it's just impossible. And the last reason is sometimes tests can be destructive. If you've ever seen car crash testing videos, they don't crash test all the cars that have been produced. They only crash test a sample of cars, just a couple of cars, to see what happens when they crash them. The reason is, once they crash the car, it is destroyed and cannot be sold. The same thing goes for food. Food will be tested before it's sold to the general public, but they can't test all the food or there'd be none left to sell. Let's say you're making a big batch of soup to feed to a whole wedding full of people. If you sampled or ate it all, there'd be none left for other people to have. So we only would sample a small bit because that test is destructive, meaning once you've sampled it, you can't use it again. So those are the four main reasons. You could probably guess at time and cost, but Sometimes it's also impossible to sample everyone, or by sampling it, it ruins it and you can't use it again. So I have a quick example next where we're going to talk about if we would have population or sample data. Remember, a sample is only a small group of the whole, whereas the population is actually the whole. So an analyst obtains the salaries of all 189 full-time professors at Cambrian College and computes the mean salary to be $90,800. These are fabricated numbers, they're not the real numbers for the salaries. Are the professors a population or a sample? In this case, the question says all 189 full-time professors. At Cambrian, that's about the number of full-time professors we have. We do not have more. If it's all of them, that means that it is population data. They have everybody that's considered a full-time professor at Cambrian. And if we only care about full-time professors at Cambrian, that's the entire population. The second example is there's a survey company called Ipsos. They survey 1,000 Canadians and report that 74% claim to be happy. Are the 1,000 Canadians a population or a sample? In this case, if we're trying to talk about Canadians in general and how happy they are, 1,000 is not even close to the whole population of Canada. That's only one small piece. 1,000 people is a piece out of like the 40 million people in Canada. So this would be considered a sample. Once you know if you have sample data or population data, there's also different names for values that you calculate from either a sample or a population. If you do have population data, like here, when they have the whole population of full-time professors and they see that the average salary is $90,800, this number that's calculated for all the full-time professors, that's the population, is called a parameter. Any number that you calculate for the whole population, we call a parameter. You usually never have the value of a parameter because it costs too much money. It takes too much time to ask everyone in the population. But there are rare circumstances where you can ask everybody. Like if the population's only a small group of people, like the full-time professors at Cambrian College, or if you're the government of Canada and you're doing the census and you have to ask everybody in the country, there are rare circumstances we could have those numbers, but it's more rare to actually ask everybody in the population. When you do ask everyone in the population, in statistics, you represent the value of parameters with Greek letters. So like mu, sigma, those are the most common ones that we're going to be using in this course, mu and sigma, for mean and standard deviation. But the important thing to know at this part of the course is that we use Greek letters for population parameters. Pi, when you have a value for the population and do the calculation, you use a Greek letter. When you only have a sample, like the 1,000 Canadians out of all the people in Canada, and 74% claim to be happy, that 74% is called a statistic because the name statistic is for values that are calculated from a sample. To tell statistics apart from parameters, they actually use regular letters like X or S or P to represent the values from the sample. One way I always tell students to try to remember if you have a parameter or a statistic is to think about the first letter. So parameter, the P matches with the P in population, and for statistic, the S matches with the S in sample. So a parameter is calculated for a population, P with P. A statistic is calculated for a sample, S with S. The fancy Greek letters are used for the parameters, and the regular Latin letters are used for the statistics. In general, like I said, we don't want to take the time or the money to actually ask everyone in the whole population. So in general, what we try to do is we take a sample. From the sample, we calculate some number, like a percentage. That would be called the statistic. We then use that statistic to estimate or to guess at the parameter. So we use the sample value to try to guess at what the percent in the entire population would be to learn more about the population. And that's exactly what Ipsos did in this survey. They asked 1,000 Canadians and found 74% claimed to be happy. They used that 74% to guess at all Canadians, the whole population of Canadians, even though they only asked 1,000. In order to make this estimate accurate, so that the statistic accurately represents the parameter from the population, so that we can use our sample data to guess at the population data, you want something that's called a representative sample. A representative sample means that your statistic accurately represents the parameter from the population. In our next part of the lesson, we'll talk about how we can get a representative sample, but for now, you just need to know that representative means that the sample will share the same characteristics as the population, so that this 74%, let's say, from only 1,000 Canadians, would be accurate to the full population of Canada. Okay, so before we move on to that and what a representative sample is, we're going to do a short example. In this example, we're going to match up some key terms. So this example is about athletes in a university, and they're trying to study their height in meters. The first thing we have is some numbers. Then we want to study the average height of athletes in the survey, all athletes in the university, a group of athletes that are randomly selected, and the average height of athletes in the university. So we need to match these with what they actually go with. So first, we have population in the list. The population should correspond to the entire group or all. So when I see this word, all athletes in the university, that's who we want to learn about. Athletes in the university, to learn about their height. So that would be my population. There we go. The sample would be the athletes that we actually asked. So if I look at something about the people I actually select, we have all athletes, and then we have a group of athletes that are randomly selected. So the ones that are randomly selected, that would be the sample that we actually take. The sample is the small group from the whole. So we don't ask all the athletes, we're only asking a smaller group, and that would be the sample. Next, we have statistic, parameter, and data. Remember, statistic would be the value or data from the sample, whereas the parameter is the data from the population. So the data we want to learn about here is height of athletes. So we're looking for which of these talk about the population or all the athletes in the university, and which of these talk about just the ones that we ask. So one of them says the average height of athletes in the survey. Those are only the one you ask. So that would be the statistic from the sample, the people that get sampled. And the other one, the parameter, we have average height of athletes in the university. That would be the data, the height. That's a number you can calculate, but for everybody in the university. So that would correspond to the population. And finally, the last thing we have is just the numbers. Once you actually record their heights, that is the data that we have, the information with some kind of context. So in statistics, using the correct terminology is very, very important. And you can see in this example that many of these answers are extremely close to each other, like average height of athletes in the survey versus average height of athletes in the university. So it's very important to be very clear in a statistical sense in terms of which data you have and what you're trying to estimate. And hopefully matching them here shows you how that slight difference in wording can be matched to like population, parameter, statistic, sample, and data. Okay. So as we continue through the lesson, the next thing we need to learn about is how you get a representative sample. A sample where the characteristics in the sample matches the whole population. So how we do that is by sampling in a correct way. So there are many different ways that you can take a sample in order to get a representative sample. We're going to learn about some good ways of sampling and also quickly discuss a way that isn't so good for sampling. For each of the methods, I'm going to give you an example of how they work. So the most common way to take a sample, and again, what I mean is we're not going to ask the whole population, we're going to ask a small group. To try to make the examples more relatable, a lot of the time we can think about Cambrian College. So at Cambrian College, the population would be all approximately 5,000 students, and a sample would be a smaller group of people that we actually ask. Let's say 100 people. You actually ask a question out of all 5,000 at the college. The simplest way to ask the people to get a representative sample would be to use simple random sampling. Simple random sampling is where everybody has the same chance of being selected. That's like drawing from a hat. So if you think of all these little people as being students at Cambrian College, these are all my students at Cambrian College. Simple random sampling would be you just randomly draw their names from a hat to help you select people to be in the sample. So they're randomly picked. And that's simple random sampling. You can do it using a computer as well, like a random number generator is the most common way to do a simple random sample now, rather than like drawing names from a hat. But either of those methods would be considered a random sampling where everybody has the same chance of being selected. Another way to sample so that you get a representative sample is to use something called systematic sampling. Systematic sampling is, let's say you have all of these students at Cambrian College that are arriving and walking through the doors at the school. In a systematic sample, you choose a number. So let's say you choose every third person. And what that means is you would then pick every third person to be in your survey. So you'd ask them your question. So 1, 2, 3, you'd ask number 3. 1, 2, 3, you'd ask again. 1, 2, 3, you ask this person again. And this method is actually really commonly used if you're actually physically at a location. Like let's say you're waiting outside of a mall and you decide you're going to ask every 10th person who comes up to the mall to participate in your survey. This gives some kind of randomness to your survey because you don't know who's going to be selected and gives people kind of, again, this random chance of being selected. So for simple random sampling, you actually have to have like a list of people with their names or student numbers or some way to randomly select them. But for a systematic sample, like imagine you're just waiting outside of a mall, you don't know who's coming up to you. You don't have like a list of people to randomly pick from because you don't know who's going to come to the mall that day. So systematic sampling can be really good because it gives you some kind of randomness that you'd ask like every third person who came up to you as an example. The next two types of samples both involve making groups of people. So the first one we're going to learn about is called stratified sampling, and this one does involve making groups of people. So for stratified sampling, imagine you've got again all your little people. But this time, instead of randomly selecting them, so everyone has an equal chance like in simple random sampling, or instead of picking them in an order like for systematic sampling, what happens in stratified sampling is you put people into groups according to their characteristics. So they have to have something in common to be in a group together. So if we're going back to our Cambrian example, let's say you go by program. So let's say these are ACGC students. Whoops, C. These are BBA students. These are, let's say, students in business. And these are students in the accounting diploma. So what these students have in common and why they're put into groups is because they're in the same program. Then once you divide people into the groups, where the groups can also be called strata, that's why it's called stratified, you put them into strata, then you would randomly choose people. So that not everybody in the ACGC program has to be selected. You'd randomly pick some people in each of the groups to then be asked the survey. But the important thing is you have to choose from each group. You can't miss one. You have to take at least one person from every group that gets formed. So what happens in a stratified sample is you form groups where the people in the group share some kind of characteristic. Then you choose from each group. The other form of sampling that involves groups is called cluster sampling. It also involves groups, but it is slightly different. Whoops. Let's go back for now. Here we go. So we have our people. And again, they're going to be put into groups, but this time, when they're divided into groups, they don't have to have the exact same quality about them. Usually for cluster samples, they're about location. So let's say this group of people is in the cafeteria. And just because people are in the cafeteria at the same time, it doesn't mean they're in the same program. It doesn't mean that one's international and one's a domestic student. They don't necessarily have the same information about them. They're just in the same location. Let's say these people are in the library and these people are at the gym. So now we've put them in groups, again, based on some kind of characteristic. But now the difference with a cluster sample is you don't choose from each group, you randomly pick clusters. So let's say the cluster I pick is the cafeteria. I randomly select that one and I ask everybody there. I could also randomly pick two clusters like caf and gym and ask everybody there. But that's the main difference between stratified and cluster sample. With stratified, you have to choose from each group. With a cluster sample, you randomly pick the cluster and then you ask the people in that cluster. This is especially important to use as a method if you're asking people from all around the world or all across the country. You can't spend that much time going to all these different places. So by doing a cluster sample, you could choose some places. Like let's say the city of Sudbury gets randomly selected in Ontario. Then the researcher only has to go to Sudbury instead of having to go to every single city in Ontario. It would take too much time and money. So cluster samples are usually used to minimize travel. So you only choose one group or one place and you ask more people there, or you could choose, let's say, 5 clusters and only ask the people there, not at every single one. It saves you time. And finally, the last type of sampling that leads to representative samples, where the sample looks like the population, is called a multi-stage sample. A multi-stage sample is just a combination of methods we previously learned about. So let's say we first do a cluster sample like we did above. So the exact same picture we did last time. Just takes me a while to draw the little men. Cafeteria, library, gym, and the cluster that gets selected is the cafeteria. What you would do with a multi-stage sample is instead of asking everybody in the cafeteria, you could then do a simple random sample and only select some people in the cafeteria. Or you could do a systematic sample and choose every third person in the cafeteria. It's just using more than one method. So let's say we do a simple random sample. First we choose the cafeteria, first we do a cluster sample to choose the cafeteria. Then we do a simple random sample inside the cafeteria and choose this person, let's say, to ask our survey. So those are some different methods that all lead to representative samples because they have randomization. Really what we want is some type of randomization so that people are given a fair chance of being included and you do not end up with all the same exact people in your survey. So people who believe the same things or think the same way. We want different types of people in the survey. So by doing a random sample, it helps to give you different characteristics and different types of people in this survey. There's also a sampling method that is not random that's used commonly called convenience sampling. Convenience sampling just means choosing individuals that are easy to ask. So let's say that I want to learn about Cambrian College students. And again, I've got all my little students. And I want to ask them my survey. The easiest students for me to ask would be the students that I teach. So if these are Jenna's students, those are the ones that are easiest for me to ask. So if I ask all of my own students and do not ask students that are not mine, that would be a convenient sample. However, I only teach students in the School of Business, in the BBA program, and in professional accounting practice. So do you think students in the BBA and students in professional accounting practice accurately represent all students at Cambrian College? Probably not, because students in the trades or in health might have different priorities about what they think is important at college or how they feel about their programs. So just because some people are easiest for you to ask, like it's easiest for me to ask my own students, it doesn't mean they accurately represent the entire population views of all students at Cambrian College. So that's why using a convenience sample doesn't necessarily mean your sample will be representative. Remember, representative means that the sample looks like the population. If I only ask my own students, that doesn't look like the population of Cambrian College, where students can be in any program. My students are only in the BBA program and in professional accounting practice. So when you use a method that's non-random, like convenience sampling, it can introduce bias. Bias means that the sample doesn't necessarily look like the population because you sampled in a way that was not appropriate. The definition says a systematic failure of the sampling method. So because the sampling method was not random, it doesn't necessarily look like the population. And that's the different types of sampling methods we're going to learn in this course. There are other types of sampling methods that exist, but some of them are quite complex, and we're going to stick to the most commonly used methods in this course. So to conclude this objective, we're going to do a quick example where we read through some scenarios and identify what type of sampling method is being used in each of these questions, again, to help you identify the differences between different types of sampling methods. So the first one says, a community college contains 3,000 students in the School of Arts and Sciences, 1,000 students in the School of Engineering, and 1,000 students in the School of Performing Arts. From each school, 10% of students are selected to participate in the survey for a total of 300 schools from Arts and Sciences, 100 from School of Engineering, and 100 from School of Performing Arts. So the first thing I want you to notice about this question is that it has groups: School of Arts, School of Engineering, School of Performing Arts. So it has groups. There's only two methods that involve groups: stratified and cluster. Stratified, you have to choose from each group. Cluster, you do not. Notice that this question says from each school. They take 300 from the first, 100 from the second, 100 from the third. So because they're choosing from each, this is stratified. The next one. Participants for the survey are recruited by flagging down students crossing the main quad of a community college until the necessary number of students have been recruited. A quad is just like a common area in the community college. So think about it like even like the Student Life Center at Cambrian College and just flagging people down. Does that sound random to you? This one doesn't specifically say like every third person or every 10th person. It says just walking up to random people in a way. So because this would be an easy method for you, but it doesn't necessarily involve randomization, that one would just be a convenience sample. What's easiest for the person, just flagging people down, but it's not random. Number 3, the student body of the community college consists of first-year students, second-year students, third-year students, fourth-year students, and transfer students. Third-year students are randomly selected to participate in the survey. So first thing is this has groups by year 1 to year 4 students plus transfer students. But how many groups do they select? Only the third year. That means that this is a cluster sample because they didn't choose from each. Stratified, you have to choose from each group. Cluster, you do not. So they only chose one group. This is a cluster sample. 500 students are randomly selected from 5,000 to participate. This one clearly says random, not just flagging down who are your friends, for example. So because it is random, that is a simple random sample. There's no groups involved. They're just being randomly selected. And finally, survey and select every 10th name from a list of students. Anything with a number like that, like third or 10th or 20th, that is what we call systematic. If you have any questions about these solutions, feel free to contact me and I'm happy to explain in more detail. The only other thing included in this sheet is a quick summary table that goes through some of the benefits and some of the disadvantages of each of the methods. So for simple random sampling, the biggest benefit is everybody has the same chance of being selected. A disadvantage is you have to know like their names or student numbers or something about them to make a list to randomly sample from. A stratified sample is good because you get people from every single group included, so you get a little bit of everything. The problem is you need to know some information about the people in order to create the groups. So for example, if I want to make groups of people by what program they're in, I need to know what program they're in, and sometimes that information is hard to get. Cluster samples are used to save time and money, especially when you're covering a wide geographic area. For cluster samples, it's hard to make groups, again, because you need to know information about the people in most cases, so it has the same issue really as stratified sampling. For systematic sampling, you don't need to have a list of people beforehand. Like think about people just coming up to the mall and you're picking every third person, so it makes it a bit quicker than simple random sampling. But it also is less random. Convenience sampling is the easiest to use, but it's not random. That's the disadvantage. And multi-stage can be the most accurate, but it does take more time and money again. Okay, so we are nearing the end of the lesson. Just a couple more things that we need to talk about is we started the lesson with talking about what the study of statistics is and breaking it into descriptive and inferential statistics. For inferential statistics, we needed to know what a population and a sample were. So that's what we learned about next, what a population and sample are, and how you can take different types of samples is what this last slide we did was about. But now we kind of want to go back to the beginning. And once we collect data, whether it's from a population or a sample, there are other ways to classify it. So it doesn't matter if you have data from a population or a sample. No matter what way you've collected it, there are other ways to classify it. And it's important to be able to classify the data that you collect because depending on what type of data it is, you'll analyze it in different ways. So in the next lesson, we want to already start to analyze data. And how you analyze that data will depend on what type of information it is. So the first definition we need is for a variable. A variable is just what it sounds like. It means it can have varying or different values. For variables, we put them into two main categories, and both of those categories start with a Q. They can be considered qualitative, or way down here, quantitative. Those are the two main categories, qualitative versus quantitative. In order to distinguish them, I'm going to go back up to qualitative and start there to help you understand what that type of variable is, and then we'll discuss quantitative next. So qualitative means that the variable is usually sorted into a category. For that reason, another name for a qualitative variable is called a categorical variable. Depending on your professor and depending on the textbook, people use the names interchangeably. That means it can be called qualitative or it can be called categorical. The name doesn't really matter, and I think both of the names are important because categorical contains the word category. That helps you to remember that these are variables that can be sorted into categories. Qualitative, the first part of that word is quality. What that means is you're using qualities to put people into categories. An example of that is hair color. You're using a quality about a person, like red hair, blonde hair, black hair, to put them into a category. So that would be considered a qualitative variable. Or gender, female, male, non-binary. Those are qualities about the person that we use to put them into categories. Your program code, like ACGC or the BBA program, is also a categorical or qualitative variable. The type of vehicle you drive, even letter grades like A, B, C, D, or F, those are categories you can put people into. I want you to try to think of a qualitative variable. There's really an endless list of possibilities. You could say something like the type of laptop you have, like if you have a Mac or a PC. You could say something like eye color, like if your eyes are blue or brown or green. It would have to be some kind of quality that you use to sort people into groups. A special type of categorical variable is called an identifier variable. An identifier just means that every single person has their own unique value. So essentially, it's a type of variable where every person gets their own individual category. Like the name implies, they're used to identify people, like your social insurance number or your student ID number, your bank account number, your driver's license number, all of those types of numbers that can just belong to you and not belong to another person. So qualitative or categorical, the names can be used interchangeably. They put people into categories based on qualities that they possess. Quantitative, on the other hand, is a variable that can be reported numerically, so it's a number. What's important about that number is it's actually a count or a measurement. What I mean by that is something like a student ID is technically a categorical variable. Even though it's a number, that number is just assigned to you at random. It doesn't actually say anything about you. It's not measured or it's not counted. It's just assigned at random. A quantitative variable has to be something numerical that we count or measure. Common examples are height, weight, distance, time, any number of people that you can count. Another important one would be money. Anything that you can count or measure. Speed in like kilometers per hour, that's measured. So anything that has like units typically that you can think about, it doesn't even have to have units because it can be a number of people or number of items, just that one single number. But anything that you can count or measure would be quantitative. I forgot a T. There we go. If you have quantitative variables, we can further break down quantitative variables into two other categories. If your number is finite and is like a whole number you can count, then it's called discrete. So if you're counting the number of people in a class or children in a family or bedrooms in a house, those can only have whole numbers and they're things we count, so they're called discrete. If you have a number that can have a decimal and it's something you measure, we call that continuous. So your height could be 157.5 centimeters. It could have a decimal. Your weight could be 180.23 pounds. The time in seconds could be that it took you 15.25 seconds. Anything that can have a decimal that you can measure, that's a continuous quantitative variable. So both discrete and continuous are quantitative. They're measured numbers, but discrete is an integer. That means it's a whole number, something you can count, whereas continuous is can have decimals. It's something that you measure. If you want to break this down, I've got this nice little image. Does our variable tell us the quantity of something measured? If it's something you measure, then it's quantitative. Farther than that, you can break down the quantitative into two other categories. Discrete, if it's a whole number, and continuous, if it's decimal. Also from categorical, you can get something special called an identifier if you have a number that's unique to someone. So only one person per number or per item. That makes it an identifier variable. So to help you with this classification, I've got some examples we're going to go through together to say if first they are quantitative or qualitative. Again, qualitative is just another word for categorical. And for ones that are numbers that are quantitative, we'll say if the variable is discrete or continuous. So first, the number of pairs of shoes you own. That is a number, so it would be quantitative. The number of pairs of shoes should be a whole number and not a decimal, which would make it discrete. The type of car you drive. If we're classifying it as things like Toyota versus Chevrolet versus Subaru, that would be categories, making it qualitative. Distance from your home to the grocery store, that's a number that you measure, so it's quantitative. And it can have a decimal, so it would be continuous. You could say it's exactly 2.5 kilometers, so it could have a decimal, it's continuous. The number of classes you take per school year, that's a number, but it should be a whole number, right? You don't take half a class, you should take a whole number of classes, so that would be discrete. The type of calculator you use, if we're putting that into categories like cell phone or scientific or financial, that would be qualitative. Also, if you're sorting it by brand, like Texas Instruments versus like, I don't know, another brand, like Sony or something. If you're going by brand, it would also be qualitative because it's putting it into categories. Weights of dogs at an animal shelter, that's definitely a number. So it would be quantitative. And again, a weight is something that you measure that can have a decimal, making it continuous. A hotel rating out of 5 stars, 1, 2, 3, 4, 5. This one is a bit tricky because if you just say the number 1, that is a number. But if you're thinking about it like this, like a star or 2 stars, that's more of putting things into categories. So I would say this one's more qualitative. It's not really a real number. It's more putting it into a category based on how good you feel it is a quality you think it has. So I would call that one qualitative. And finally, IQ scores. That one's reported as a number, and usually high IQ scores are reported as whole numbers. So because it would be a whole number, we would say it is discrete. So that's the last example. Most of them are numbers, but we do have some qualitative values in there as well. So the very last thing we have to learn about is related to classifying variables, but it's another way to classify according to what we call levels of measurement. So not only can we classify variables as qualitative versus quantitative, we can also classify them according to how much information they give you. Being able to do this classification is very important because when we start to learn some statistical calculations in the next lesson, you can't do every calculation for every single set of data. It depends on what type of data you have. So being able to classify according to these 4 different levels of measurement will help you to know what type of analysis you can do. So the 4 levels of measurement are called nominal, ordinal, interval, and ratio. We're going to go through them one by one. Nominal gives you the least information and is the lowest level of measurement. And then you progress through the scale until you get to ratio, which is the highest measurement that has the most information. So the first level is nominal. Nominal is this type of qualitative or categorical. So you put people into categories. But specifically, it's categories where the order doesn't matter. Things like your hair color, it doesn't matter if you put brown or black or blonde first, the order does not matter. Same with gender, male, female, or someone reports non-binary or prefer not to say. The order does not matter there, just as long as you list all of the categories. Another one would even be your program. It doesn't matter which program you put first, if you put them alphabetically or reverse alphabetical, just as long as you list them all. Related to this is ordinal. It's one level higher because, again, it's qualitative data. You put the variable into categories based on the qualities, but for ordinal, order matters. So that's the one difference. Nominal is just used to name categories, but for ordinal, order matters. So things like your letter grade, A, B, C, D, and F, those are categories, but you know that order matters, that an A is higher than an F. Things like what place you finished in a race, like I got first place or I got second place or I got last place. Or even things like if someone asks you, how important is this course to you? Like very important all the way to like not important. Those are categories, but you know that there's an order in them. Even something like breakfast, lunch, and dinner. Those are categories, but there is an order in the day that they take place. So if you can order the categories in some type of way, then that gives you a little bit more information than ones where the order doesn't matter at all. So nominal is the lowest. It's putting it into categories where the order does not matter. Ordinal is next. You put into categories, but the order does matter. The next level is called interval. Interval is where you actually have a numeric value. So this would be quantitative. There's a difference between the numbers, like there actually is numerical values, but there's no meaningful zero. What that means is 0 does not mean you have an absence of the quality. There's not that many examples of interval data, but a very common one is temperature. Another one is IQ score. Let me explain these. So temperature is a number that you measure, but it does not have a meaningful zero. What I mean by that is when it's 0 degrees outside, that's just a point on the scale that was chosen where we kind of switch between like the warmer to the cooler temperatures in Celsius. But 0 degrees does not mean that there's no temperature outside. It just is another point on the scale. Same with IQ score. When you write an IQ test, you get a score at the end. But if you got a 0 on the test, does that mean you don't have any intelligence? No, it doesn't actually mean you have no intelligence. It's just a scoring method that was chosen on the test. Another example could even be like your dress size. Women's dress sizes go all the way to 0, size 0. But because you're measured as a size 0 as a number, does that mean that your body doesn't exist and you don't have a size? No, it's just a point that was chosen to represent a small clothing size. It doesn't mean your body doesn't exist. So these are numbers, but where the 0 doesn't mean that there's a lack of the quantity. It's just a point that was chosen on the scale. Like temperature, 0 Celsius and 0 Fahrenheit are not the same thing. They don't mean no temperature. They just are a point on the scale that was chosen to distinguish, I guess, the different temperatures. And finally, the last level with the most information is ratio level. Ratio is a number, it's quantitative, and it does have a 0. So basically things like money, if you have 0 money, you actually have none. Weight, if you weigh 0, it actually doesn't exist. Length, if it measures the length of 0, it's not there. Time, if it takes 0 seconds, it doesn't take any time. So basically anything that you measure that has a meaningful 0, which will be most things. There's the exception for things like temperature and dress size, but almost anything you measure and is quantitative is usually ratio. Interval, like I said, is that weird one where there's not that many examples because it doesn't have a real 0. So to recap, nominal is qualitative where it goes into categories and the order doesn't matter. Ordinal, it goes into categories, but the order does matter. Interval, it's a number you measure, but there's no 0. And for ratio, it's a number you measure and there is a meaningful 0, meaning that when there's 0, you have none of it. Like if money, if you have $0, you have nothing in your bank account. So let's go through the exact same examples we already did, but this time try to classify them as nominal, ordinal, interval, and ratio. The number of pairs of shoes you own. That's a number. When it's a number, it will either be interval or ratio. If you own 0 shoes, do you actually have none? The answer to that would be yes. So that means it's ratio. It has a meaningful 0. The type of car you drive. Toyota, Chevrolet, Ford. Does it matter the order? No. So that would be nominal. Distance from your home. Anything with length is ratio. The number of classes you take per school year. Again, that's a number. You count it, and if you take 0, you actually are not taking any classes. So again, that would be ratio. The type of calculator you use. The order does not matter, and that would be categories like Texas Instruments, Samsung if they make a calculator, etc. Weights of dogs at an animal shelter. Weight is one of the ones I listed for ratio. That would be ratio because it has a 0. Hotel rating, if it's stars out of 5, like 1 star, 2 stars. Earlier we said that's qualitative. For qualitative, we have nominal and ordinal. For number of stars, order does matter. We know 5 stars is way better than 1 star. So that would be ordinal because it's putting it into categories, but we know which one is best. And finally, IQ score. We talked about that as being one of the rare examples of interval data because it's a number, but 0 is just an arbitrary point that was chosen on the test. It doesn't mean you have 0 intelligence if you got a 0 on the test. And that is the last example in this lesson. The final thing at the bottom of this sheet is that you have a table that shows you the different characteristics. So for nominal data, it's just put into categories, nothing else. For ordinal, you can put it into categories and order it. For interval, it's a number. So you can classify it, you can order the numbers. They're numbers with a measurable difference, but they don't have a real zero. And for ratio, you get all four things. That's why it gives you the most information. So if you actually have a real number, you can do a lot more analysis than if you have a category like male, female, or 1 hotel star, 2 hotel star, 3 hotel star. So being able to classify the level of measurement will help to decide what type of data analysis you can actually do with your data that you have. So this was our introductory lesson to what statistics is. We started with our title page and then worked our way through the definitions of what statistics is. Once we learned about what statistics is, we talked about sample versus population data, since those are necessary for inferential statistics. Then we talked about the ways you can take samples. Finally, once you've actually taken a sample and collected data, we talked about how you can classify the data as qualitative or quantitative, discrete or continuous, and finally, classifying according to level of measurement. That's how much information the data gives you. How much information the data gives you is pivotal to what analysis you can do. In our next lesson, we're going to actually start doing some analysis with data that has been given to you or collected. Thank you for watching this video. For every single lesson in the course, they'll be formatted in a very similar way, where you should be filling in the Excel workbook as you work through the lesson. I will also provide my completed version of the workbook that contains all of the notes within it so that you can review it at any time you need to, so that you should have your own completed copy, and you can also download the professor completed copy if you missed anything or you need to review any part of the lesson. So thank you for watching this video. If you do have any questions about the content, please email me and I'll be happy to meet with you to set up an appointment or we can review any of the course content. Thank you. Bye.